on this one?
Yeah. No.
No, there isn't. So there's nothing to pull out. The reason you want to look for greatest common factor first is smaller things are easier to factor in general. Smaller is easier, but there's no way to, for example, let's say each of those numbers was even. Instead of 6, let's say it was 16, 12, 16, 24, and 8. What could you pull out?
8. 2.
Actually, you pull out, in that case, you pull out an 8, actually, because 16 is a heap, yeah. But 2, you start 2, and then you pull out a 4, and you get down. This one, there's nothing you can pull out first. But you know that the first two have to multiply together to get what? 15. So maybe 5p and 3p. That's one possibility. Or it's switched, right? And what about the ones at the end? What do they have to multiply together to get?
8p squared.
And you know, let's say 2q and 4q. And is it going to be pluses or minuses?
Plus.
It's going to. Why do you know it's pluses? They're all positive. There's no negatives here. Exactly. So what do you have to do at this point?
Divide by...
No, divide it. Multiply. You just have to test it. You have to test it. You will test tons of these in your life. You will test tons of them. So let's see. First two, you get 15p squared plus 20pq plus 6pq plus 8q squared. Is that close?
Wait, where did you get 20p?
5p times 4.
2 off.
Yeah, hold on. Just go one at a time here. We're close. We're 26pq instead of 24. So let's maybe switch the order of one of them maybe? What do you think? Yeah. So how about we try instead 5p plus 4q and 3p plus 2q. Let's see what that's going to be. Well, that's 15p squared plus 10pq plus 12pq plus 8q squared. What do we have there? 22pq. Are we? Look, we went 2 under, so we flipped and went 2 under. Oh, it's interesting. So I understand. So the question is, this is where the hardest part of factoring comes in. Have you tested every possible? We're not going. You don't need to test negatives. That's not going to do anything for it. But are there any other orderings we can test? Yeah.
We're flipping 5 and 2.
Let's flip 5 and 2 instead. Not 5 and 2, 5 and 3. You can switch the 5p and the...
Oh, yeah.
Yeah, so instead, how about 3p plus 2q and 5p plus 4q? What do we get here? 15p squared plus 12pq plus 10pq plus 8q squared. So does this work?
No.
So what do we think this is? Prime. Now here's the thing. If you don't show work, you will get no credit on these. You would have to show 3 of these in order to prove it's prime. And remember, just because something could be prime, if that's a possible answer, doesn't mean they're all going to be prime. You can't be like, oh, it's prime, it's prime, it's prime, it's prime, it's prime. No, it's not. It's not. This one's kind of frustrating because are you really close twice? Yeah, it's a little frustrating. Okay, moving on. Who has got another one? So, is there a GCF on this? Yeah. So what could we pull out? How about, let's pull out -2. I want to pull out negative because I like the front thing being positive. If I pull out -2, what does the first term become? 6a squared plus 5a plus what? 21. Now on this one, the leading, so you just keep that -2 out front, and what are you factoring on this one?
6a squared.
You're factoring this right here. So you can just put that -2 out front, and you've got 2 things here that need to multiply together to get the green. Now, what's kind of annoying is 6 is 2 and 3 or 6 and 1, but which one do you want to try first?
2 and 3.
Let's try 2 and 3. So 2a and 3a. And what do the other 2 numbers need to multiply together to get? 21. But the middle number is pretty small, right?
Yeah.
The middle number is pretty small. So we have to be careful about putting big numbers places. 7 and 3. Are there any other factorizations for 21? No. So here's one possible way, plus 3 and plus what? 7. But is that going to work? No, you're getting a better sense of this, so you should, because this works out right to get there. These 2 go there, but what's 2a times 7? 14 plus 9 is 23a. That's not 5a, right? So what's the only thing you can do when you're testing this out? What's the only other combination you can test? What? No, if it's positive, it has to stay positive. You could switch what and what?
2a and 3a.
You could switch these, right? But is that going to change the middle term that much? No. It's not going to change the middle term that much. So if you do this one out, you end up with 6a squared plus 14a plus 9a plus 21, and that is not what you want, right? So the only other one you could test would be 2a plus what? 7, and 3a plus what? 3. Is that going to work? No, that one's going to be, I think, what do we hear? 6a squared plus 6a plus 21a plus 21. That's too big as well. So on this one, if you had factored it, you would stop there. You said you watched the video. Did you have an observation? So now we can test this. Now maybe is this factorable?
Yeah.
Possibly. So again, no, that negative 2 is just floating out front. So maybe 3a and what? 2a? So what factors do we want to use here, do you think? Negative 3 and what? If that one's negative 3, this has to be positive 7, right? Do you agree with that?
Well, 7 minus 3.
7 times 3 is going to be 21. That's pretty big, right?
Yeah.
So is this going to work? Do you think this is going to work?
Okay.
6a squared plus 21a minus 6a minus 21. What does this come out to be? 15a. Is that what we want there? No, we want 5a. So that doesn't work. What's one thing we could change about this?
2 and the 3.
We could change the 2 and the 3. So instead of this being
Or
3,
you can have negative.
hold on,
7
one at a
plus
time.
3.
Correct? Let's do it this way. Let's do the one you suggested. So now we do it this way. 2a times 3a is what? Plus what? 14a minus 9a, right? Minus what? Wait, does this work?
Yes.
It does.
I'm having deja vu. I've dreamt about this before.
Nice.
That's problem. Serious.
Awesome. So did we find it? Now, do you notice how I was erasing things? So it's really nice on these surfaces that you can perfectly erase things, but when you're testing all the different ways to factor something, you need to keep track of what you've tested, or you might not get to all of the ways, and then you might get frustrated and keep on going, prime, prime, prime. No, no. I can guarantee on a test I'm going to give you like maybe one thing that's prime. Gabby first. Easiest thing to pull out of both of these. 2. So start there. 2 and it's 16c squared minus 49d squared. Oh, now do you recognize what that is? What is that? It's a minus sign. Which special one is that? Yeah?
Difference of perfect squares.
Difference of squares. Correct.
Why? Oh.
Why is that difference of squares?
No, I was going to say, why would you pull out the c squared, but it's c?
It's c and d. Exactly. You can't. So why is that a difference of squares? Because you have, what do you have? Something squared minus something else squared. What goes in each of those?
4 and
4c and
7.
7d. So do you remember when it's a squared minus b squared? It's a plus b times...
A minus B.
Exactly. So this is going to be 2 times what, Noah?
4C
Plus
70
times.
4C minus 70.
Done. There it is.
How come you don't do
That's fine. So what do you end up with? A squared minus?
b squared?
So that's why it's true. So over here, instead of, in this case, what was A? 4C. What was B? 7D. And then you put it in. It's A plus B times A minus B. Like right there. Another one from 6.3. What do you got? What can you factor out on the left? Oh, sorry, on the right. On the right.
2.
Where?
Okay.
Oh, wait. No, you start with the left. Wait, what?
No, you can factor out 2.
Hold on, you could. So I just asked you, what could you factor out? I didn't say whether or not it was going to work, but could you? You could go, okay, it's 2kh plus 2. What's the problem over here? Is there any way to get that?
It's prime.
That's, well, it's seen before. So let's go back. Did we have any, did we have special patterns yesterday?
Yes, I don't get special patterns.
Well,
Neither do I.
okay, well, did you actually look at them?
Yeah.
Good. So now we're going to actually practice it again. There we go. So now we have special patterns here. So let's see if any of them actually look like what we want. What could you do? Hold on, what could you do?
Switch the first negative with
No, you can't switch. You can only factor. So we can factor out a -1. If we factor out a -1, can you tell me what this is?
K squared.
K squared
Minus K.
K minus 2kh
Minus 4.
plus what?
Squared.
Plus h squared. This thing right here should look familiar or look like one of the ones down there. Which one does it look like? The second, let's say line 2 or line 3. Which one does it look most like?
3.
It looks most like 3, right? Because we have the first 3 terms. What would those first 3 terms be? K squared minus 2kh and what?
Plus H squared.
Plus h squared. So let's just do something here. Can you, what's that rule? You can move the orders around with addition, right? So we could have -1 k k squared minus 2kh plus h squared minus 4. But what does this right here exactly look like? Look at the purple lines, everybody. What do we have? X squared minus 2xy plus y squared. K squared minus 2kh plus h squared. We're ignoring the 4 for now. We're just looking at the purple right now. This right here is what?
X minus y squared.
So what is this going to be?
X minus y squared.
I don't see any x's and y's there.
Well, K's.
K minus h squared.
Ah, so what do we have here? Minus k minus what?
X squared.
Squared minus what? 4. This purple, you see the purple, everybody? It's all the same. This form is exactly the same as this one. And what does this factor into? This. You've picked also, this is pretty much the hardest one I think on the homework, so be okay with the fact that it's okay if this is a little difficult. So, do you see how this looks exactly like the one up there? What do we have? X squared minus 2xy plus y squared. K squared minus 2kh plus h squared. It's the same form. So what does this equal? What does it equal?
X minus y squared.
X minus y squared. So what does this equal?
K minus
Stop saying that, and please answer the question with the words that are on the board. K minus h squared. Here's the even more fun part. Are we done yet? No, we're not. What do you see now?
The negative.
I see. Let's see if you can figure out what you see. What could I put in that blank parentheses?
2.
Oh, what do you see right here?
Oh, that's the.
What is that called? Hannah? What's that called? You have two things squared and you have a minus sign. What's that called?
Oh, the difference of
Difference of perfect squares. This is the difference of squares. This is the difference of squares. So what was that formula? A squared minus b squared is a plus b times a minus b. So what does this turn into? K minus h plus 2 times what? Times k minus h minus 2. So what does this actually factor into? K minus h plus 2 times k minus h minus 2. This is a very hard factoring problem. I would give you at most one of these. The things that you need to most pay attention to are the pieces. The pieces being, do you see this first purple thing right there? Recognizing that so that you can factor from this purple to the second purple. But then when you see squares, you should think, is this the difference of squares? So for example, let's just say I gave you this. 16 minus 27, sorry, 16 minus 81. How could I rearrange that? What could that be? What is that equal to?
4 squared minus 9 squared.
4 squared minus 9 squared, so what's that equal? 4
Minus 9.
4 plus 9 times 4 minus 9. I use numbers just so you can see it, but that's the pattern. The key is that this one is hard because it's just a lot of things put together into one problem. This is a challenging factoring problem. This is challenging. Practicing factoring is the only way to get good at factoring. Yes, Chris?
So
It's all difference of squares. In the first one, it's h plus k squared minus 3 squared. In the second one, it's, instead of 16, what do you write it as?
4.
4 squared, so x plus 3y squared. And in this case, it's 8 squared minus plus 2t squared. And in each case, here they are. Here's A, and here's A right there. And what about B? There's B, and there's B. So now you just, kids, shh. Now you just need to follow the pattern. You just follow the pattern. So what's the first one going to be? H plus K minus 3, or plus, you can do first, times H plus K minus 3. And you could clean that up a little bit and just make it H plus K plus 3 times what? H plus K?
H minus K?
No, it is not. That is A. H plus K, it's glued together. That is A. So what about the second one? What's this one going to be?
4
plus
x plus 3y
Times.
4 minus x plus 3y.
So if you simplify this, it turns into 4 plus x plus 3y times what? 4 minus x minus 3y.
What-
Yeah.
Wait, how come it's minus now?
Distribute, gotta distribute the negative. Gotta distribute. And what about this one? 8 minus, well, a plus, sure, r plus 2t times
8
minus r plus 2t. So if you simplify this, you get
8 plus r plus
Mhm.
2t
times
8 minus
r.
minus 2t.
Correct. There you go. You've done the difference of squares. Okay, so let's keep going here. These are the patterns that are a little bit hard to remember, but based on what you see right there, please no, 6p, there's no second p, plus what? Plus 9. That would be a great one. Y what?
Y plus 1 times
Y minus 6. Nice, it worked. It does. Okay, so
Why don't they tell you anymore?
I want to put these on the board. Pick any 3 you want out.